Okay, hi guys. So in this lecture, we'll be seeing n factor for bases. So let's get started. So number of moles of OH minus furnished or produced by 1 mole of base is the n factor for base. Number of moles of OH minus furnished or produced by 1 mole of base is the n factor for base. So this is by Arrhenius, and by Bronsted-Lowry we can say that number of moles of H plus accepted per mole of base is Bronsted statement. Okay, so for NaOH and KOH, n factor would be 1. Okay, for ZnOH whole twice or MgOH whole twice, as in cases of acids, n factor can be 1 or 2, and max n factor would be 2. Okay, let's see some example. We have ZnOH whole twice aqueous reacting with 2 moles of HCl aqueous forming ZnCl2 aqueous plus 2 moles of H2O So here n factor of ZnOH whole twice would be 2, and it would be considered as a diacetic base. And here the n factor for HCl would be 1. Okay, so next let us see the n factor of amphoteric substances. Substances like NaH2PO4, Na2HPO4, NaHCO3, etc. Okay, so these all are incomplete salts. Okay, so if we have H2CO3 plus NaOH gives us NaHCO3 aqueous plus H2L. So this is obviously incomplete neutralization. So we get these salts or amphoteric substances as a result of incomplete neutralization. Okay, let's see some examples on it. So suppose we have NaHCO3 aqueous plus NaOH aqueous. This gives us Na2CO3 plus H2L. So n factor here would be, this would be considered as an acid, and n factor here would be 1. N factor here is always 1. Okay, next let us see this substance. We have NaHCO3 aqueous reacting with HCl aqueous forming H2CO3 plus NaCl. Okay, so in this case it would be acting as a base. Okay, n factor still would be the same as the previous reaction. Okay, So this is the nature of amphoteric substances. They can either act as an acid in certain reactions and as a base in the other. Let's see some more examples of NaH2PO4 aqueous when reacting with NaOH aqueous forms Na2HPO4 aqueous plus H2OL. So here it is acting as an acid with N factor of both the acid and base as 1. Okay. Let's see another example where we have NaH2PO4 aqueous plus 2 moles of NaOH aqueous reacting together to form Na3PO4 aqueous plus 2 moles of H2OL. Okay, so in this case again this is acting as an acid here with N factor of 2, and here it would be acting as a base with N factor of 1. Okay, let's see another example of NaH2PO4 again in aqueous medium reacting with HCl aqueous forming H3PO4 plus NaCl. So here NaH2PO4 would be acting as a base, as NaH2PO4 is an amphoteric substance. It can either act as a base or an acid. So here N factor of this would be 1. Next, let us see the N factor of elements. So N factor of elements is determined by their valencies. Okay, so for sodium, potassium, etc., the N factor would be 1. For calcium, zinc, N factor would be 2, and for aluminium N factor would be 3. Okay, next let us see N factor of ions. So N factor of ions is determined by charge on them. Okay, so we have K plus, Na plus, H plus, OH minus. N factor of all of these would be 1. If we have Ca plus 2, Cu plus 2, SO4 minus 2 or 2 minus, N factor of all of them would be 2. And if we have Al3 plus, Fe3 plus, PO4 3 minus, N factor of all of them would be 3. So in the next lecture we'll be continuing on seeing N factor of compounds, and then we'll be seeing equivalent weights. So till then, good luck and goodbye.